notion we had before with that picture, where the relative n chains are essentially where everything in the subspace is identified, concrete, at least for whatever that nice subset polyhedron is. So, let's see. So we've been talking about things in top squared, essentially, with this relative homology. So the next thing he does is gives this definition. So this is the, let's see, I'll do it over here. So if you have f, g from x, A to y, b, we say f is homotopic to g mod A if there exists f from x cross I, comma A cross I to y cross b with f naught f and f1 equal to g. So they say this notion of homotopy mod A is weaker than the previous notion of homotopy rel A, since we don't require anything stays fixed. So this is, I guess, a weaker notion. This is sort of the natural notion of homotopy for top squared, because from it we get this theorem 5.19, which is the last theorem in the section. So if f and g maps and top squared, and f homotopic to g rel A, and for all n equal to 0, the nth, or the induced maps are the same. And essentially the proof here, they use an exercise to get a commutative diagram, and essentially, let's see here, we're trying to reconstruct the maps from lemma 4.21. So they don't really even supply the details there. Essentially they just say proof now proceeds exactly of that of theorem 4.23. Right, so essentially what you need to show after you've constructed those maps using the exercise is we have that property we need to show that these two maps are homotopic, namely partial p plus p partial is equal to map induced by lambda 1 minus map induced by lambda 0. And that's section 5, chapter 5.
Sort of anti-commute modulo the number maps. Interesting. Like if you thought about it, you got partial p bar equals minus p bar partial plus the number maps. Whatever those things are. Sorry, I don't often find anti-commuting things. So it's cool. I'm just ignoring the number maps for the sake of finding something anti-commuting. Makes me happy. Cool. Thank you, Nathan. So you'll be For those of
I think I have taken up all your time.
those devoted fans of Nathan's chill lecture style, you coming back again in a future episode when?
Oh yeah, when is my future episode? I think I'm doing
Natural.
chapter 10.
Chapter 10?
If we get there. No, not chapter 10, is it?
Chapter 9 maybe? No, let's see. Where is that thing?
Chapter 9. Which will be in a future where I don't have to study for the GREs. and
Goodness
then
gracious, I think you could easily spend 5 class days expositing chapter 9 from the look of it. Anyway.
Yeah, we'll see what happens there, because we want to get to, chapter 12?
That is
At least.
That is the dream. I want to skip ahead to cohomology.
I wonder if that's a very good idea.
Probably not.
I don't think he has, like a dependency chart for the different chapters at the beginning of the book. It's probably just linear, for the most part.
It's an exact sequence.
Yeah, we might have to find a way to have some more time at the end or something once we're more free. We go for a marathon meeting or something after finals.
That's terrifying.
We're more free.
Let's see here.
We'll become free of dealing in groups.
Let's see here. So what's up next? Chapter 6 is excision. Good grief. Excision and applications.
Where we actually get to show stuff.
See here, we will learn such things as homologies.
If m does not equal n, then r to the m and
Yes.
rn are not homeomorphic.
Man, it is crazy how much machinery it takes to get to that, isn't it?
You get actually proof the Brouwer fixed point theorem.
That thing, I mean, the fact that it's this far into it to get to that, goodness gracious. But this homology of spheres, of course, the Yowzers. Barycentric subdivision. Not sure what that's for. Let's see here.
I think that was mentioned way back in chapter 2.
Mm-hmm. We got the degree theorem for a fungus, I guess a smooth, but not smooth, continuous function from the circle to the circle. The degree of the function is d of f. What's d of f?
D of f is just the function that takes the function to its degree.
Oh, okay.
Which
And
is kind of weird. I don't know why he just didn't use degree for that, but
Well, what's degree
he
of f
had
then?
2 separate. Huh?
What's degree of? And I mean, this
Degree
theorem is saying degree is degree.
Is this back from like the winding number stuff?
Was it? It's yeah. It's from the winding numbers. Like you got f from I
Okay.
to S1, right?
Yeah.
How do you write it? S1 or S1? I guess it's S1. Yeah. So if you have this,
Right. Oh, the Hurwitz math is in your.
then the degree of f is equal to what? I think they use f squiggle
Mm-hmm.
of 0, where this is the unique lifting with. No, maybe it's 1.
Oh yeah.
This was the unique lifting with
Right.
f squiggle 0 of 0. Yeah.
Then we get to the antipode and antipodal maps, and the fact that the antipodal map has degree -1 to the n plus 1. Did we already Mayor Virtuoris? Is Mayor Virtuoris earlier in this chapter?
Yeah, it's like at the end.
That's at the end or is it at the beginning? Oh, right there. Yeah. That's important. You can that allows you to do like a fair amount of explicit calculation if I remember right. Mayor Virtuoris sequence. And then what else we got here? Vector field. There exists no non-zero vector field on. Wow, this chapter is just chock full of stuff that I care about. Sorry, I mean I care about all of it.
Wait, what theorem were you talking about?
Theorem, page 123. The corollary 6.27 actually.
Very well.
Yes. Theorem.
Oh, the Hairy Ball theorem.
There exists no antipodal map from the M sphere to the 1 sphere. Cool. Yeah, these theorems that we get about mappings on spheres from topology are really fascinating. Really fascinating. So I guess I got my work cut out for me next time, huh?
Yep.
Oh, wait a minute, this was
I've
you were
spared
doing
you
this
for
one.
now.
You were doing this one, Daniel, right?
I think so.
Which one are you doing?
Well, I actually looked and it said I wanted to do chapter 6.
Woohoo!
I hadn't like prepared for it before today, so if you want, I can do it.
Are you doing it?
It's shorter than chapter 7.
Are you
so
okay?
like,
I mean, or do you
somewhat
need to
tempted
prepare for the GRE?
I don't know, I might be able to
Doesn't matter.
throw something together. We'll see.
Okay, so if you're doing, I mean, it's good for you to do chapter 6. It really is the computational core of this course.
Okay.
So that would be smart. Oh man, I was obfuscating for no reason.
You're doing it on my behalf.
I still remember. I well remember in complex analysis when the student asked me, what about the polar form of the Cauchy-Riemann equations? And I immediately thought, that's weird. This student is disinterested. The student never asks anything. That's a very specific and interesting question. Why are they asking it? And so I went into it, you know. And then at the very end of class, she's like, well, since we didn't get to talk about blah, does that mean the homework on blah is not due now? I was like,
You're a monster. Exploiting my weakness.
bad person. Yeah, I should have told those students, no, you cannot join this independent study. You can wait till next year and take it again with Dr. Kester. Because you failed the course doesn't mean you get to take it again because I'm doing a favor for a student who has proved themselves to be hardworking and blah 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 blah. So anyway. Oh well, what's done is done.